to this talk on Introduction to Micronaut and GraalVM. For those of you who don't know who I am, my name is Graeme Rocher. I am the creator of a couple of pretty well-known frameworks in the Java space called Rails and Micronaut. I'm currently working as an architect at Oracle Labs. A few years back, I won the Oracle Groundbreaker Award for the work I've done on open source. I'm a Java champion and alumni, and I'm leading Oracle's contributions to the Micronaut framework. So on the agenda today, we're going to look at the background that led to Micronaut. We will do an introduction to Micronaut, an introduction to GraalVM. We'll see how well they work together, and we'll do a whole bunch of Micronaut demos. So in terms of the background that led to Micronaut, if you look at traditional architecture, which is illustrated on the left-hand side here, versus modern architecture, where in the traditional case, Java applications were built into WAR files or EAR files and deployed to a Java virtual machine, a single Java virtual machine in the form of a Java container, whether that be Tomcat or a Java EE container or whatever. And they all shared the same memory space and the same Java virtual machine. And that allowed, the Java virtual machine to optimize memory across the applications and to take charge of things like observability, management, and monitoring across the whole virtual machine. Now, on the right-hand side here, we have modern architecture, where instead of a single Java virtual machine, we have these individual Java virtual machines, which are typically running inside a container, Docker container. And they are typically orchestrated by some orchestration layer, typically Kubernetes, in the cloud. And each application has a unique Java virtual machine, which, as you can imagine, loses out on the opportunity to share memory across the applications and pushes the manageability and monitoring and observability down into the orchestration layer. So as I mentioned, in this kind of traditional versus modern apps scenario, we have your traditional approach being with servlet Java EE containers using a single shared VM. And on the right-hand side, you have an orchestrated layer with separated containerized Java virtual machines. Typically, traditional applications are built with monoliths and deployed as WAR files, whilst modern applications are quite often published to Oracle, to container registries, whether that be Oracle's one or whoever's one. And in the traditional frameworks that targeted these Java containers, things like Spring and CDI, they made extensive use of techniques that are not great from a memory consumption and startup performance perspective, which was maybe okay when there was a shared single Java virtual machine across all your applications. But techniques like reflection, runtime bytecode generation, runtime generate proxies, and dynamic class loading in general have adverse effects on memory consumption and startup. The kind of micro reality of where we are today in these modern architectures is that frameworks that are based on reflection and annotation has become pretty fat pretty quickly, but folks already really enjoy the programming model that these annotation-based programming models have provided. In fact, annotation-based programming models in the Java space are still the most popular way to build applications. And if you turn these features off, which you can in most cases, and you can kind of handcraft your application, then the drop in productivity is massive. And in general, there's a correlation between the lines of code that you have in your application and your startup time and memory consumption. The more lines of code you have, the higher your startup and memory consumption is. Okay, and all these problems are pretty much common across all different frameworks that are implemented based on annotations. Because there are essentially limitations that if fall down into the Java virtual machine in terms of if you do things at runtime, there is just no way around these things. There is a limited annotation API in Java, which is only really available via reflection. The Java virtual machine, with generics being added later, makes extensive use of type erasure, so that in order to get to find out whether something is a list of string, you have to use reflection to figure that out. Reflection itself is generally slow, or slower than direct method dispatch, and that has led to many different solutions being built, from things like cglib, and Java Assist and ByteBuddy, which tries to essentially generate bytecode at runtime in order to improve reflective method dispatch. And the other problem is the proliferation of reflective data caches. So in the case of, if you imagine your typical Java stack today, where you have something like Spring, Hibernate, and Jackson, each one of those libraries will essentially maintain its own cache of reflective data that it needs in order to perform tasks like dependency injection, serializing objects to JSON and back, and storing objects in the database and back. There's no kind of shared cache in Java for reflective data that can be used consistently across libraries. So each library tends to produce its own, which results in memory consumption suffering. And another major problem is component discovery and class path scanning. Typically in a Java application, you want to find out all of the classes that are annotated with a particular annotation, whether that be at web servlet or at controller or at path in JAX-RS. And in order to do that, most frameworks that are implemented at runtime have to implement some kind of form of class path scanning, which is very slow. And the other challenge is in order to just support things like redeployment at runtime that traditional Java containers do, they have very complex class loader hierarchies, which can be expensive to load classes from these hierarchies and can introduce problems into your application. So all of these problems, and some of them, for example, with reflection, are easy to understand. If you look at reflection, for example, today the Java virtual machine and JDK are all open source, and they're all on GitHub. So you can navigate to the source code of the JDK, and you can go to the java.line.class file, and look how our reflective data is accessed. And if you look at how reflective data is loaded, essentially as soon as you access any reflective data for the first time on a class, whether it be a field, a constructor, or a method, all of the reflective data for that class is initialized and stored in what's called a soft reference. A soft reference is essentially not garbage collected until the application is low on memory, which is clearly undesirable behavior. And in terms of the raw cost, in our profiling, we saw that one java.lang.reflect method occupies around about 100 bytes of data in memory. Now, you may not think that's a lot, but as your application grows and you have thousands of methods and thousands of fields and thousands of constructors in a larger application, we've seen applications that end up using hundreds of megabytes of memory just on reflection due to this problem. So that led us to building Micronaut a few years ago. We started working on it, in fact, 3 years ago. The goal of Micronaut was to learn from what we had experienced with building Spring and Grails and so forth, and take a completely new, clean room approach to rebuilding how a framework is designed, eliminating all of those problems that we encountered in the construction of Spring and Micronaut. So you can think of Micronaut right now as clearly a microservice serverless focused framework. But it's also a tool that can be used to build any kind of application. So anything that has a static void main is a target for Micronaut. It's also a Java annotation processor. So what does that mean? It means that it hooks into the Java C compiler and essentially computes your framework infrastructure compilation. So we like to think of Micronaut as compile time framework infrastructure. And it's essentially the result of 10 years of lessons learned building Spring and Grails applications. So like I said, Micronaut is build time framework infrastructure, essentially. And It hooks into your compiler, and at compilation time, it computes all your dependency injection and configuration injection, all annotation metadata, so that annotation information can be accessed without using reflection. Everything to do with AOP proxies and so forth is computed at compile time. Bean introspection, so that you don't have to use java.beans.introspector, which was based on reflection, to, for example, dynamically instantiate objects and read it to read and write them to, for example, JSON or a database or so forth. And it's completely reflection, runtime proxy, and dynamic class loader free. And that was a big goal of the framework. So like I said, with Micronaut, you can build a whole range of applications. You can build microservices, you can build serverless applications, you can build message-driven applications that listen to Kafka or RabbitMQ streams. You can build CLI applications, and in fact, the Micronaut CLI itself is built on Micronaut and computed into a native image. You can even build Android apps. You can build anything that has Delegate main, and it supports 3 languages currently, which is Java, Kotlin, and Ruby. So Micronaut has had a big impact since it was open sourced. It was open sourced just over 2 years ago now, and or announced 2 years ago and open sourced. And it's generally sparked industry-wide improvements from companies like Red Hat and VMware with Spring Boot, trying to improve performance to catch up with Micronaut. And it's really changed the face of people's expectations of how server-side Java should perform. And the ideas and principles have propagated into other communities. For example, there's a quote from the creator of .NET Core at Microsoft, where the principles in Micronaut have really kind of influenced many of the things in .NET. In terms of what is GraalVM, for those of you who don't know what it is, it's a new virtual machine out of Oracle Labs that is able to, in JIT mode, increase your application throughput by between 20% and 30% and reduce latency and response times. It's also able to take an application and compute it into a self-contained native binary, which is great for cloud deployments and native image, essentially, because it dramatically reduces memory consumption and start time. And it also includes a truffle language framework, which allows you to seamlessly interoperate and use multiple languages and libraries. So for example, you can, from Java code, you can call JavaScript, and JavaScript can call Java code, and there's no overhead in terms of interoperating between different languages. Micronaut loves GraalVM in that Micronaut and GraalVM Native Image, which is the part of GraalVM that computes native images, are a match made in heaven. And they are a match made in heaven because essentially, anytime you do anything dynamic with GraalVM Native Image, you have to configure it and you have to declare it. So if you use dynamic class loading, if you use reflection, if you use runtime proxies, that has to be configured ahead of time to tell native image about these usages. Whilst on the other hand, Micronaut is completely free of any runtime reflection, runtime proxies, bytecode generation, and dynamic class loading. Therefore, when you use it with native image, there's pretty much nothing to configure because it's already configured and ready to be native imageized, if that's a word. So Micronaut and GraalVM work really well together, and it reduces your startup time down from, which is pretty fast still for Java. So Micronaut starts up in around 700 milliseconds with Java, but all the way down to 20 milliseconds with native image, which is great in terms of serverless and cold start performance. And it also dramatically reduces your memory consumption down to 18 megabytes, which is pretty sensational. And those numbers are essentially orders of magnitude improvement of the virtual machine. Now that comes with some trade-offs. Obviously, native image compilation times are longer, and you lose some of the capabilities of the JIT, but it's still a pretty decent trade-off for certain workloads, CLI apps, serverless apps, certain kinds of microservices, for example. So how do you get started with Micronaut? So you can go to Micronaut launch. You can go to launch.micronaut.io to get started, and it basically generates a Micronaut application for you. It's a website, and the application itself is actually, the backend is written in Micronaut, and it's running completely serverless on the backend, and it's computed into a native image. So the cold starts are amazing, and it's using Micronaut at the map. And it's accessible via the browser or via curl. If you want to contribute to the UI and or the backend, the source code is at that link. But to get started building Micronaut apps, just go to launch.micronaut.io and get started. So with that, that's enough talk, and I'm now going to do some demoing of Micronaut, which is, I guess, the more exciting part. So I'm a CLI guy, and what that means is that I prefer the CLI to creating Micronaut applications, and rather than going to launch.micronaut.io. And the Micronaut CLI is pretty cool itself because it is written in Micronaut itself, so kind of eating our own dog food, if you so to speak, by building the Micronaut CLI in Micronaut and computing it into a native image. And it's interactive, so you can drop into this and you can say, I want to create an app called demo, and I want to add, for example, features, data JDBC, and you can create your app. And your app is created. You can then see the Intuit and open it up in your favorite IDE, for example. There we go. Here we go. Now, whenever I open an application in IntelliJ, I do like to modify IntelliJ to run my tests with IntelliJ, just because it provides a nicer experience in my view. And to help demo this better, I'm going to go into presentation mode so that we can see things better. So this is my Micronaut application. We have an application class, which this is what it is. So it allows you to, I can right click here and run my application directly from my IDE, and it will start up, and there it is, operational. I can also run tests. So it comes with a default test. So here is my application, which just tests that the application starts up correctly, and we can run that. And it will start my application, bootstrap it, and so forth. Now you can see that this is a full integration test that's testing the startup of my application and making sure it's running. And one of the goals of Micronaut and one of the benefits of extremely fast startup time that you get with Micronaut is how quickly it is to run tests. So as you can see, I can run this test and it's really, really fast. Now, in terms of what it feels like to use Micronaut, let's create a person class. So this is going to be my person class here. And one thing you can do with Micronaut is you can annotate any kind of POJO that you want with introspected to allow you to dynamically instantiate it and so forth. So I can add something like a couple of fields here, like so, and we can make this an immutable object, just having getters. So there's my person. And maybe you want to add validation rules. So you should have, this should not be blank, for example, and maybe we want to constrain the size. Now, one thing that's interesting here is that in the Java, in a regular Java framework where you have to do everything at runtime, the framework would have to reflectively break Java encapsulation rules by going in and accessing this field, private field, and to get the annotation information on it. The other thing about the JavaVM spec is that it allows you to define annotations of either the name or the getter. So for example, I could have an annotation on here that limits the size to, say, 50 characters. And now I've got two places where I'm defining annotations, and that puts the burden on the framework that has to go in and analyze those two locations. But not with Micronaut, because it's all computed for you at compilation time. So how would I use this? So let's create now a person test, for example. So here's my test class, and this is going to be a JUnit 5 test. So I'm going to add test person, and there we go. So so what you can do is you can say bin introspection or get introspection person, and get hold of an introspection like that. Then you can say introspection.instantiate and create a new person like so. There's Fred, and then we can say it's equals, and we expect Fred's age to be 45. Replace that with static import and run my test. There you go. So as you can see with an introspection, and this is one of the kind of key building blocks of a framework, is that you want to be able to dynamically instantiate and objects, in this case person. And how do you do that without reflection? And what Micronaut does is essentially at compilation time, if we look inside my build directory, you'll see that Micronaut is actually producing an additional set of classes that sit alongside your classes that allow you to do those things at compilation time. at runtime, but by producing those references at compilation time, so it doesn't have to be done at runtime. So you can also do things like take the introspection and get a required property from it. For example, we want to get a property from it. For example, we want to get the name property that is type string, for example, if we know ahead of time what type of type it is. So that gives me a property. And then you can do things like assert equals thread, for example, and we can say property.get from thread. And now we're going to actually dynamically read the name from the thread object, but again, reflection-free using the bean property that I obtained up here. And the other thing you can do with the bean properties and this API is essentially work on the annotation metadata. So I can get, for example, the annotation metadata from the property, and I can say annotation meta, get annotation names by stereotype and pass in constraint, and get all the different annotation names like that, and maybe iterate over them like so, and output them like that. And what you'll see is that when I run this, you can see it outputs down here, size and not blank. And that's because each, for example, not blank is annotated itself with constraint, and size itself is annotated with constraint. So Micronaut provides a kind of meta annotation API for allowing you to query annotations without using reflection. And that's key for when we perform things like serializing to JSON or deserializing. Micronaut hooks into Jackson and replaces the Jackson serializer, deserializer to be reflection free using the annotation metadata that it's able to compute at compilation time. So what else can you do with Micronaut? So you can, for example, create a person controller, and let's now expose some data. And this is going to be a controller that's going to expose like a people endpoint, and maybe we're going to have a get request come in to here, and we're going to expose a list of people like so. And maybe we want to have the implementation of this stack by a service of some description. So this could be my person service, and over here we're going to have a list person method, more or less. That's going to list all the people like so, and we can do a return arrays.as list, new person Fred maybe 45, and maybe having another person here who's going to be 55 named Bob, and probably we need to import that. And there we go. There's my person service implementation. So now how do I get hold of a reference to person service? We just use dependency injection. So I can inject this in here into my constructor, and we can add a constructor there. And then we can say return person service dot list people to return all the different people from my person service, which I currently just hard coded into memory. So how would I test this? And again, we can go into create a person controller test. And this time, what we're going to do is we're going to annotate this test with @Micronaut test. And what that will do is it'll bootstrap the application into the test, so that we can test against it. I'm going to test list people, and in order to test this, I'm going to write a simple interface, which is going to be my person client. Now, you could use the low-level client to make requests, but I find it's far more fun to use this way, and using the declarative client. So we can say @client, and maybe we can go into our controller and just copy the signature here, like so. So we're going to make a request. Then we can inject this person client into my test, and we can say client.list and list all the people, and then we can do something like this equals to list.size, replace that static import, and run my test. So let's see how that goes ahead. So there you go. So that is a full-on integration test that's loading my application, and it's I created this application with Micronaut data JDBC, and it's creating a data source and everything in the file and everything. And you can see I can execute these tests like super fast, and it feels like unit testing, functional testing, and integration testing. Micronaut apps feels like unit testing because it's so fast. And if you don't believe me that that's actually a real request, you can come into the logging configuration, and we can say logger name plus io.micronaut not HTTP client, and we can say I want to enable trace level logging, and we can run it again, and there we go. We got input and output coming out. So there we go. That's how simple it is. So how would I add data access to this application? So let's say we want to use a relational database. As you saw, when I created the app, I used Micronaut data as a feature. So I can just say, this is going to be a map entity, and the only other using Micronaut data. And the only other thing we need to do is we need to make sure that we have some kind of database ID. So I'm going to add generated value as my database ID, like so, and maybe a couple of getters to a getter and a setter to get and set this. And then maybe we want to set up some data. So I'm going to have a event listener on here that is going to have init startup event. So so this is going to be fired every time the application starts up, and then we're going to do person service. We're going to want to save some data that we can retrieve, and before that we actually need to make this access the database. So how do I do that? We're going to say this is going to be a JDBC repository, and it's going to use the dialect h2. We're going to make this into an interface that extends from a CRUD repository, like so. And this is going to be a person class. And we can just get rid of this for the moment. Whoops, trying to get rid of all of that, my imports. So now my person service is a data repository. And instead of using find all, instead of doing this, we can just use find all, which actually returns, why is that an error? It returns an iterable. Oh, right, okay, so we probably have to override this find all, and instead of an iterable, return a list, like so, and now that should be working. So there we go. And then what we can do is we can say person service dot save all, and stick in my code that I worked out before, like so, and save all my data. And in theory, if the demo got with me, which they don't appear to be, that's a weird error. Rebuild the project just in case. Okay, so run it again. Okay, so now it works. For some reason I have to do a rebuild. So now we have a full-on database application. So it's my test is passing again, and you can see in this time in the response we've got database IDs coming back, ID1 and ID2. So this is a full database app, which is, and if you don't believe me, you can come into the logback configuration. You can say logger name equals io.micronaut.data.query, and we can enable trace level logging again on the query logger. And now you can see the queries are going back and forth. So inserting people on startup and querying, you see in there the select being executed and so forth. So that is how simple it is to implement a database application. So how would I take this application to being native? So what you can do is you can essentially, from your terminal window, you can say, if I were to build a regular application, I could just assemble it into using Gradle or Maven or whatever build tool you chose, and then you could do java.r.libs to run the application like that. Now, if I want to build a native image, you can just say GraalVM Native Image. And this will essentially use GraalVM to build me a native image from this application. Now, the native image build process actually takes some time, so I'm going to continue with my presentation so that and then come back and revisit it, and we'll have a look at what kind of startup performance that we get. But essentially, once you have a native image, you can expect a significantly better cold start. So these are graphs that we obtained from using the Micronaut plus GraalVM Native Image on Oracle Function for serverless, where you essentially see dramatically better cold start performance in the native image side, when the blue bar is native image and the green bar is the regular JVM. In terms of the status of Micronaut itself, it's really a healthy project. It's actively developed by a variety of different organizations, from object computing to Oracle to contributions from Google and so forth. So, a very diverse set of committers working on the project, 4.2K stars on GitHub, a lot of commits, and that's through the link to the repo. So do star that repo and follow us on GitHub. So if we come back, it's still building my native image. So in summary, the Micronaut and GraalVM are leading the AOT revolution in terms of allowing you to build applications using ahead of time technology, pre-computation, framework infrastructure, pre-computation native images, in order to create more efficient applications that are more efficient at runtime for workloads like serverless, like microservices. And you can see in this case, once I built my native image, if I run it here, you can see that the startup time is dramatically reduced from the kind of 800 milliseconds, I think it was, for the Java version, down to 29 milliseconds. It's still doing the database access and so forth. And if we, look at the actual memory consumption performance, I'll probably have to, do a quick search. There it is, applications. So you can see up in the corner there, the overall memory consumption is 20 megabytes for this application, which is a dramatic improvement over the regular Java version. So that's what you get with AOT. AOT sacrifices compilation speed to gain so much more, and it's a trade-off in terms of longer compile times, but far more efficient applications at runtime. Building more efficient applications is absolutely possible today with the right framework choices. So, so you can, using a framework like Micronaut that computes your framework infrastructure, provides dramatic efficiencies. And going native now today, it's a reality today with GraalVM. So that is my presentation in terms of some Micronaut resources. Yeah, we have a Git community where you can come chat to us. Go to github.im/Micronaut framework. The user guide documentation can be found at that link, .io/documentation.html, or I think docs.micronaut.io works as well. If you want to generate your own app, do go to launch.micronaut.io. You've got guides on a variety of topics, from serverless to all sorts of things, at guides.micronaut.io. Do follow the framework on Twitter as well, twitter.com/micronautfw. And do star us on GitHub. We'd love to hear feedback from all of you. So with that, I have now time for some questions. Hopefully the audience has many. So the question is, how do you write GUIs? Question one is, how do you write UI interfaces? So there is a variety of ways to do that. There is a sub-project in Micronaut called Micronaut Views, which you can get to from Micronaut project/Micronaut Views. And you can see the documentation here. And it provides support for server-side view rendering if you want to go the server-side approach. So it has support for things like time leaf, handlebars. You can see all the list over here. Apache Velocity, FreeMonker, Rocker. Rocker actually works really great with native image, because Rocker is the view rendering technology that is completely reflection-free and it's build time. So if you're looking at like native image support, some of the other ones may require additional reflection config, whilst Rocker is like great for native image. All of them do support though native image. We have made sure all the view rendering tech works with GraalVM. So those are the different view rendering options out there for Micronaut, and so forth. So next question is, which Micronaut 2 serverless? The first one, do you have to fetch all the beans from bean context to build the function handler? That's really up to you. You can make, Micronaut has a variety of ways to make beans initialize eagerly or initialize lazily. There's all sorts of different ways where you can say, I want to initialize all these beans. Now, for Lambda specifically, it's actually very efficient to initialize the beans that you're going to use as part of the static initializer. So you can, it's actually a good thing to specify which beans you want to use. And there's an annotation in Micronaut called add_context, which you can specify that says, I want this bean created on startup. And that works really well with Lambda, so that you can, because Lambda prioritizes CPU initialization for function initialization. So if you leave any initialization for when the function executes, it can actually be slower, which is clearly not a good thing. In terms of HTTP clients, for Micronaut, we have a built-in HTTP client that's based on Netty. But of course, you can use whatever HTTP client you want, including the built-in JDK one that ships since JDK 9, I think it is. So whichever one you want. And which libraries do you recommend for production use of Micronaut? Well, again, that's completely up to you. It depends on your production requirements. You know, there's Micronaut data, you know, supports all major databases. You know, it's hard to say. Production requirements vary greatly. Scaffolding also for Kotlin. Yeah, so if you go to Micronaut, either start.micronaut.io or launch.micronaut.io, and you go here, you will see that you can select language. You can say Java, Kotlin, or Groovy, or Maven or Gradle, and we even support Kotlin. For Kotlin, we support CodeTest as well, which is a Kotlin testing framework. So there's quite a variety of options. In terms of how that plays out on the CLI, what you can do is in here, I can say mn create app Kotlin demo, and I can say lang, and again, you can do that interactively if you want. I can say create app Kotlin demo lang, and then you choose the different languages that you want. Kotlin test, you can choose the test framework you want, so I want CodeTest, and it will create your app, and that's it. So Kotlin scaffolding works as well. Another nice thing about the Micronaut CLI is if you see into the app and then drop that down into interactive mode, you can do things like create controller example, and it will create you a controller and a test, and you can see that it's because I've created a Kotlin app, it's generating the Kotlin controller and test in Kotlin. So we have scaffolding, including for more extensive use cases like generating code and so forth. Okay, so we have support for Kotlin coroutines as part of React support. Yes, since Micronaut 2.1, we have added support for suspend functions and like HTTP client and caching and in a whole bunch of areas. There may be gaps. I don't know. We're getting a lot of feedback from the Kotlin community. And actually, regarding the Kotlin community, we track how many people are creating apps with Micronaut Launch, and just like percentages and so forth. And currently, around 30% of the apps being created for the Micronaut are in Kotlin. So we have a very large Kotlin user base. The vast majority, of course, are Java, but it's still quite a bit. So is there a deployment process for Kubernetes is the next question. So yes, so the deployment process for Kubernetes is basically Gradle Docker build. And that will build you a Docker image, which you can push to a container registry. You can do Gradle Docker push, which will push to a container registry, and that's which you can then configure with Kotlin. Now, in terms of additional Kubernetes support, when you create your app, you can choose the Kubernetes feature. We have a bunch of integrations for Kubernetes, including support for Knative and Kubernetes. And if you choose that and you enable it, what happens is, if I click this preview button, you'll see that it generates an additional file called k8s.yaml. When you create your app, it'll create the deployment, pointing to the appropriate health checks, health and readiness endpoints, and set your application up all ready to be deployed to Kubernetes. What is the way to write an Android app with Micronaut? So there is a sample application and somewhere, and we have, there's actually a variety of ways. One way, if you're using Java for Android, clearly you can use Micronaut as a DA container in much the way you would use Dagger or something like that. And we have that working. And another interesting way is a project called Gluon HQ, I believe it's called, which actually allows you to use Micronaut as a DI container and compute a native image for mobile using GraalVM. And we have prototypes of using this Micronaut plus Gluon plus native image deploying to iOS and Android, which is really an interesting possibility for the future. Okay, so what plans for the future of Micronaut? So we have a lot of plans for Micronaut in the future. We want to expand Micronaut support for document databases, reactive database SQL access. We want to support more messaging systems. We have great support for Kafka and Q, but there's many other messaging systems out there. We want to expand Micronaut into the IoT arena because it's really being used a lot for IoT use cases because of its nice memory profile and so forth. So more support for IoT. And we want to continue to improve the integration with GraalVM such that whatever feature you use of Micronaut, it always works with native image, regardless of the library. And that's the long-term goal, that you should be able to build anything and everything should run on native image. So a question about multiple data sources. So to do multiple data sources, you can see that I've got a default data source set up here, which is data sources.default. If I could create another one here just by dropping in, and this would be other, and this would be other DB to create another database. And then in my repository, what I can do is you can target the particular database by using the repository annotation. So I can say repository other, and this will target the other database, and I can have multiple databases, repositories for each database, or etc. Okay, so any plans to merge Grails and Micronaut? No. Grail, well, yes and no. Grails is already using Micronaut in that Grails 4 includes Micronaut itself into it, so that you can use Micronaut's Rabbit client and Kafka client and HTTP client and inject any Micronaut bean. But Grails is great at what it does, which is typical traditional applications, front applications, targeting a rapid application development framework for traditional applications deployed as raw files to things like Tomcat, database-centric with CRUD screens and so forth. Another question, so is it possible to use Micronaut data to JPA? Yes, absolutely. So obviously I demonstrated usage with JDBC, but if you go to the Micronaut data website, you'll find, or repository, which is here, you will find documentation, and actually the main way to do Micronaut data is with JPA. So we have a Micronaut data hibernate JPA implementation. Oops, I don't know what happened there. Suddenly my font went crazy. Yeah. So yeah, this, there we go, there it is. So you just add this and you make sure the processor and you configure it, and then you can use Hibernate or JPA annotations, and it's the same. We generate queries for JPA and so forth. So completely doable. Thank you very much for attending this presentation, and I hope you enjoyed it.